Let C belongs to R. The union of two neighborhoods of C is also a neighborhood of C. Proof. Let S1 contained in R and S2 contained in R be two neighborhoods of C. Then by definition there exist open intervals A1 B1 and A2 B2 such that C belongs to this open interval A1 B1 and this open interval A1 B1 contained in S1 and C belongs to A2 B2 contained in S2, since S1 and S2 are two neighborhoods of C. Now there are two possibilities, either this or this. Now in this case A1 B1 open interval contained in A2 B2, or in this case open interval A2 B2 contained in A1 B1. Only these two cases are possible. Now from this interval A1 less than B1 and A2 less than B2 and A1 less than B2 and A2 less than B1. Also from this A2 less than B2 and A1 less than B1. So first we write A1 less than B1, A2 less than B2 and A1 less than B2 and A2 less than B1. So from these two, A1 less than B1, A2 less than B2, A1 less than B2, A2 less than B1. Similarly this also. So both are same. Let minimum of A1 A2 equals to A3 and maximum of B1 B2 equals to B3. So from the figure now from this A1 B1 union A2 B2 equals to A1 B1 union A2 B2. This is, now see from this figure, A2 is less than A1 and minimum of A1 A2 is equals to A3. So from this A1 B1 union A2 B2 is equals to A2 B2, and from this A1 B1 union A2 B2 equals to ki A1 B1. So now combining two cases, in this minimum of A2 and A1 is A2. So here we write A2 and a minimum of A1 A2 equals to A3. So therefore A2 equals to A3, and maximum of B1 B2 equals to B3. Here maximum of B1 B2 is B2, therefore B2 equals to B3. This is B2. Now, from this case, here A1B1 union A2B2 equals to A1B1, and minimum of A1A2 is A1, so A1 equals to A3. So therefore this is to A3, and maximum of B2B1 is B1. Therefore B1 equals to B3. So B3. So combining two cases, A1B1 union A2B2 equals to A3B3. Therefore A1B1 union A2B2 equals to A3B3. We have to prove union of two neighborhoods of C is also a neighborhood of C. So we take union of two intervals and we get this equals to A3B3. Now A1 B1 C belongs to contained in S1. Therefore A1 B1 contained in S1 union S2. मैंने सेट को बड़ा कर दिया तो उसके अंदर भी तो A1 B1 contained होगा. Similarly A2B2 contained in S2. Therefore this implies A2B2 contains in S1 union S2, and obviously C belongs to this open interval, and obviously here also C belongs to this open interval. So we get A1 B1 contained in S1 union S2 and A2B2 contained in S1 union S2. Therefore इन दोनों का यूनियन A1 B1 union A2B2 also contained in S1 union S2. Then A1 B1 union A2B2 equals to ki A3B3. Therefore A3B3 also contained in S1 union S2, and obviously C belongs to this open interval A3B3 contained in S1 union S2. So ultimately we get A3B3 C belongs to this open interval contained in S1 union S2. From the definition of neighborhood, this shows that S1 union S2 is a neighborhood of C. S1 union S2 is a neighborhood of C. So we prove this union of two neighborhoods of C is also a neighborhood of C. Proved. It is to be noted that union of finite numbers of neighborhoods of C is a neighborhood of C. Finite number. In next video, we will discuss about intersection of two neighborhoods of C. Video ভালো লাগলে অবশ্যই share, subscribe and comment. Please.